Hey, Team Impact. Rocking and rolling. It's Thursday, I believe. One more day to the weekend. We're going to crank up mean absolute deviation today, or another word we're going to call it is just mad, right? They had mad comics and mad comic books when I was a kid, but the mean absolute deviation is an interesting piece of statistical data. All right, and what it's going to tell us today is the average distance. Each number is from the mean. All right, so it's really kind of the mean of the mean if you think about it. We have a lot of vocabulary to do. There's a lot of steps. I'm going to pause this just for a second so I can grab my phone for a calc. Okay, I'm back. I just wanted to grab my phone so I could use it. The buttons are a little bigger for my bigger fingers. So anyway, all right. Hey, let's get after this. One way to describe variability, variability, or how spread out a set of data is by using the mean. Let's write that absolute deviation. We talked yesterday about deviation, about deviating from a path, how far numbers are off of another number. For example, yesterday we talked about measures of variability. Remember, we talked about the IQR which was the interquartile range, and we talked about the internal spread of the data. This is just another way to talk about deviation, how far it is out. Mean absolute deviation is the average distance that the data points in a set of data are from the mean. Right? So I always like to think of it as the mean of the mean. The mean of the mean. A MAD close to zero, and look how I write zero, means that the data values are close to the mean. So the closer to zero, all right, the closer it is to the mean. All right. How do we find the MAD? Well, first off, we're going to find the mean of the data set, the mean. So we're going to add them up, and then we're going to divide by the total number in the set. Okay. Next up, we're going to find the distance from each data point and the mean. So we're going to subtract the two. We're going to subtract the two. And sometimes, guys, you're going to get a negative number there, but always just write the absolute value of that. So just write, and let's just write that now. So let's always write absolute value of this number. Okay. And you'll see what I mean. But just write the positive of it. So if it ends up being 1 minus 4 and you get -3, just write 3 down. All right. And you'll run into that in just a minute. And then find the average of those distances. So we're going to find the mean of the mean, as I just said. Okay. Very well. So let's get into this thing just a little bit deeper. And first up, we're going to take this data set right here, and we're going to find the mean. So I'm going to pause it and let you do that now. So I've got a mean of 18. And if you didn't get 18, the sum of the digits was 126 divided by 7. And that's how I got 18. Now, what we're going to do is we're going to look to the left. Okay. And what we're going to do here is we're going to subtract this mean from all of our data points. And then we're going to write that difference right there. So 20 minus 18 is 2. 19 minus 18 is 1. Okay, and I'm not going to do that every time, but I wanted you to see that. 15 minus 18, here we are. This is the 1, so it's 15 minus 18 is actually -3, but we're going to write the positive of that down. And let me write that 3 a little better, okay? So we want to write the positive of that. 23 minus 18 is 5. 14 minus 18 is -4, but we're going to write the positive value of that, okay? And then 17 minus 18 is -1, but the absolute value of that is 1. And then 18 minus 18 is 0. Okay? 0. So to get these numbers, I showed you up here, these first three, uh, we just subtracted this from the mean. Now, what we're going to do is add all of these up. 2, 3, 6, 11, 15, 16. So our sum of those numbers right there is 16. Okay. Now, letter A, B, I guess this is C. Find the average of the distances or the mean absolute deviation to the nearest tenth. So that means we may have to round, right? Okay. So I'm going to take 16 and I'm going to divide that by 1, 2, 3, 4, 5, 6, 7 again. And when I take 16 and I divide that by 7, I get a big long decimal. See it? So I'm going to round that to the tenths place. So I'm just going to do that. And I'm going to end up with 2 3/10. Now, going through all of that, what does that tell you? That tells you that the average distance, these numbers right here, are from the mean is 2 3/10. So it's really the mean of the mean, as I told you. And that's how we calculate the mean absolute deviation, or what we call the MAD. So the average distance is 2 3/10 away from 18, which was the original mean. Okay. All right, let's flip the page. Let's see what's on the back here. Fun, fun. Okay, let's try this again. We got a couple more pieces here. Next up, it says find the mean. So I'll pause, you find the mean, and then I'll see in a second. So I got 6 there. Now, what I'm going to do is I'm going to subtract each one of these numbers from the mean. Whether it's positive or negative, I'm going to write the absolute value, which is it's positive, right? Okay. 3 minus 6 is -3, but I'm going to write 3 down. 5 minus 6 is -1, but I'm writing 1. 8 minus 6 is 2. 10 minus 6 is 4. 4 minus 6 is -2, but we write that down. And 6 minus 6 is 0. Okay? All right. Any problems so far? All we did was subtract this from our original numbers, which was in our data set. Okay, so now we're going to add these numbers up. 3, 4, 5, 6. 6 and 4 is 10. 12 and 0 is 12. Okay? So now we're going to take the 12 and we're going to divide it by the total number in the set, which was 6. And that equaled 2. So what does this number tell us right here, the mean absolute deviation? The average distance, these numbers right here are away from 6 is 2. So the average distance away from the mean is 2. Okay? Very good. Very good. How you feeling? Feeling pretty good about yourself? Okay, I want to pause the video. I want you to attack number 3. Okay, attack number 3. All right, we're going to do the exact same thing. When you click it, come back on, all the answers are going to be populated on my piece of paper, but don't do it. Don't click it unless you're done. Okay, you can take a peek at mine. I had a mean of 7. I subtracted all of these numbers from 7. And remember, 2 minus 7 was -5, but I took the absolute value. Added them up, got 16. Divided it by 5 numbers in my set, so I found the mean of the mean. The average distance is 3 2/10 away from the mean. So I hope you're feeling good about that. All right, number 4. Coach Jackson found the mean absolute deviation for the number of minutes it took his PE class to run a mile. Okay. The mean absolute deviation was a very large value. Jaden assumes this means his class took a long time to run the mile. Do you agree with his conclusion? Well, no, I don't agree, because I'll tell you why. The mean absolute deviation does not tell us individual data, it tells us as a group. It tells us that the class's spread of the data was very wide, meaning this. Let's say that Johnny ran the mile in 4 minutes and 15 seconds. And then I came along and I'm in the same class, and I ran it in 7 minutes. And then Jane ran it in 10 minutes. And then Josie ran it in 4 minutes. So all of that is telling us is that we have a variety of milers. We have a big spread of the data. Okay, so it's not giving us specific data. The MAD tells us. The MAD tells us what about the variability of the data, the deviation, right? Those words. It tells us about the deviation of the data, not specific. Okay, not specific. So understand that. And this is as important as understanding as doing all this. You've got to be able to interpret your data. Okay, so if you flip it over, you can see that you're going to go through your homework 1 through 6. Take your time, set it up. Okay. And what we're going to do tomorrow, which is Friday, is we're going to review all 4 lessons. All right, so we're going to have a good review day. Have a good day, guys.